Okay, so the underlying geology is going to determine what the pattern is for the drainage. Here is a map of the United States, and the different colors represent different drainage basins. So the big drainage basin in the middle of the country is the Mississippi Drainage Basin. Over here in North Carolina, we have a bunch of drainage basins, and we will look at some of those in a bit. Okay. The pattern then, this first one, I've used that word before, dendritic, and it means tree-like, so it's branching like a tree. The underlying geology is going to be rocks of uniform strength. So from one geographic location to another, the rocks will be the same. Vertically, they may be different, but they are going to be flat-lying rocks, so following the rule of original horizontality, like the image below, and those different tributaries are going to be draining that landscape. So that's one, the dendritic tree-like pattern. Next is radial, and these are like spokes of a wheel. And here in this image is a volcano, and the small streams are going to come together into trunk streams and form a radiating pattern away from that center of the mountain. So it can be a volcano, or it can just be a conical shaped hill or a mountain. It doesn't necessarily have to be a volcano, it just has that shape. The next kind is a rectangular pattern, and a rectangular pattern is really going to reflect the underlying cracks in the rock, and we call those cracks joints, and they oftentimes are found in sets. So in this image, parallel lines represent joint sets in this direction and in this direction. So those joint sets are going to make a grid pattern, and the streams are going to follow that grid pattern. So that's a rectangular drainage pattern. Next is a trellis pattern, and in this case, the underlying geology is going to be alternating between rocks that erode pretty easily and then rocks that have are a little bit tougher and are harder to erode, like a hard rock. So in this case, we have a resistant ridge followed by a valley that is maybe the rock type shale, S-H-A-L-E, and the ridges are oftentimes something like the rock type sandstone. So sandstone ridges and shaly valleys. So it looks kind of like a trellis where you have these tributaries that come in and feed a trunk that maybe is cutting across those more resistant ridges. The Shenandoah Valley, if you ever drive up through Northern Virginia and into Pennsylvania, you'll be driving down valleys and look to either side of you on the highway, and there are these resistant ridges. The rivers can cut across those resistant ridges, and that's called a water gap. Okay. Those are drainage patterns. Let's define what is a drainage basin. You may have heard the term watershed or a catchment basin, and those mean the same as a drainage basin. Generally, a watershed is the area of land drained by a stream or network of streams, and you can think of it like a bowl with an outlet. So in this block diagram here, we have two drainage basins. On the left is drainage basin A, on the right is drainage basin B. It's kind of a bowl shape, and the stream here is coming out of the bottom of A, and then B comes out the bottom of B. Down the center of these two bowls is the divide. So that is dividing one drainage basin from another. So when rain falls on this block diagram, the water that hits to the left of the drainage divide is going to flow eventually down through stream A. Water that falls to the right of the drainage divide is going to eventually flow down into stream B. All the water is going to exit that one spot. Here's a quotation by John Wesley Powell. He was the first director of the USGS, U.S. Geological Survey. And this is what is a watershed or a drainage basin. The area of land, a bounded hydraulic system within which all living things are inextricably linked by their common water course, and whereas humans settle, simple logic demanded that they become part of a community. That was what John Wesley Pell said of a watershed. They are separated, like I said, from each other by divides. So here is a map of North America, and on this map, then the dark lines are the divides. So we have the divide here to the west, the continental divide, and all the area in this orange color is water that is drained to the Pacific. There is the Great Basin that includes areas like the Great Salt Lake, where water comes in, but it doesn't drain out, it evaporates out, leaving behind a briny, salty set of lakes. To the south then, here we have the Mississippi River drainage area, and all of the water in this area is going to drain in from the edge of the eastern side of the Cordillera of Mexico into the Gulf of Mexico. And then this dark brown here, we have all of that is going to be draining into the Atlantic. To the north in the green area, the land of Canada, those glaciated lakes are all going to drain into the Hudson Bay. And then to the far north, that is the drainage area that flows to the Arctic Ocean. So some of the watersheds can be quite small, just a valley, and some of them can be continental scale, like these 1, 2, 3, 4, 5, 6, if you count the Great Basin. So these continental divides separate water that flows to different ocean basins. When we describe a watershed, we talk about it in terms of order, the stream order, and that has to do with the number of tributaries. So a first order drainage basin is going to have no tributaries. It would just be a trunk stream. Second order has 1 tributary, third order 2, and so on. You would calculate that by n is the order, and n minus 1 is the number of tributaries in that watershed. So a higher order means there's lots of tributaries in that watershed area. Here is a neat little animation of the Mississippi. Down to the Mississippi. We are over here in North Carolina, and this is the New River, and beginning the New River that flows up into West Virginia.